Hello, good day. In this virtual class, I will take us through this and how to show that the integral sine 3 root x dx is equal to minus 2 third root x cos 3 root x plus 2 over 9 sine 3 root x plus c. Okay. Here, the first thing to do is to look at the right hand side and think of an appropriate substitution. Okay, first of all, we'll let 3 root s is equals to g. Okay, then thereafter, it means that we're going to find an expression for x. Okay, so if we say that g is equals to 3 root x, it means that this integral here become sine g dx. So we need to find an expression for the x. So in order to do that, we must also try and uh, make s the subject of the formula. So by so doing, we divide this equation through by 3. So this becomes g over 3 is equals to root x. Then for us to obtain x here, we have to square both sides. To remove the square root here, we square both sides, and s is equals to g squared over 9. Then to obtain the x, okay, because here we are seeing g, so that means we need to have an expression that will get rid of the x. So the x from here is equals to 2 over 9 g dg. So if we differentiate g squared, it's going to give us 2g, and 2 times 1 over 9, this becomes 2 over 9 g dg. So we will substitute in place of the s here, we substitute 2 over 9 g dg, so that it will become integral sine g 2 over 9 g dg. So we have to need to factor out 2 over 9, and this becomes 2 over 9 integral g sine g dg. Now, observing carefully, we see that this is g times sine g dg. This is product, and the appropriate techniques for evaluating when an integral take the nature of product is to use integration by parts. Okay, here we have two functions g and sine g. So the appropriate technique is integration by parts. So here the formula is the integral of v du is equals to vu minus integral of u dv. Okay, here we have v and we have the u. So all we need to do first is to look at which of these we take of this function, or the expression we take v, and the one that we take the v. Okay, the most appropriate one is to look for the one that is easily differentiable, even though in this function g and sine g, they are both differentiable, but which of them is easily differentiable, that is, that can reduce easily, is g. Okay, we know sine we either be changing, if you are differentiating, we change from sine to cos, from cos to sine, but g, once it is differentiable, it will reduce completely. Okay, so now here we say the one that is easily differentiable will be the value of v. So v is equals to g, so that the u from here become integral sine g dg. Okay, also note, to obtain u from here, that means we find the integral of sine g, and to integrate sine is minus cos. So u is equals to minus cos g, and for us to obtain the v, we differentiate uh, the v. We differentiate v with respect to g. This becomes the v is equals to the g. So here we substitute in the formula. This becomes minus g cos g plus, now from here, the integral of u, which is the minus here times this minus, and this minus become plus, integral of cos g dg. Then since this integral of the integral sign is here, that means we still need to take care of the integral of cos g dg. So that the integral of cos g dg is equals to sine g. So if we integrate cos, the appropriate answer is sine g. Now substituting it in the formula, this becomes integral of v du is equals to minus g cos g plus sine g. Okay, So, but the integral here is multiplied by 2 over 9. So we definitely use it to affect the result here. This becomes 2 over 9 into minus g cos g plus sine g close brackets. So this will affect everything here, and this become minus 2 over 9 g cos g plus 2 over 9 of sine g. Okay, but we also know, we are also aware that g is represents an expression. So we let g is equal to 3 root x. So in place of g, we substitute 3 root x. So this become minus 2 over 9 times 3 root x cos 3 root x plus 2 over 9 sine 3 root x close bracket plus our c, where c is an arbitrary constant. Okay, here 3 here divide 3 1, 3 into 9 is 3. So this becomes minus 2 over 3 root x cos 3 root x plus 2 over 9 sine 3 root x plus c, where c is an arbitrary constant. Now, if you compare your result with what is shown here, you see that they are exactly the same. So this is the most appropriate way of evaluating this integral. Please, if you like this video, help me subscribe to my channel, and also I need your good comments on how to improve even better. Have a nice time. See you in my next virtual class.